Good afternoon, everybody. My name is Imran Hussain, and I'm joined by, very fortunate to be joined by Irvi Aini, who will be the co-speaker today, or in fact, the chief principal speaker on this great talk that we have around Bigtable. So welcome, everybody. Good morning, good afternoon, wherever you are in the world. And as always, it's a real pleasure to welcome everyone to another online session of the Google Cloud Data User Group. So the meetup is all about sharing, learning, and taking inspiration from each other in terms of the experiences that we all have in using data on Google Cloud. So that said, what are we covering today? Well, over the next hour, we'll be talking about Bigtable and some really exciting, interesting learnings there. As I mentioned, we're very fortunate to be joined by Irvi. So Irvi is a software engineer with focused interests in data engineering and distributed computing. She was previously part of Traveloka's data engineering team, where she contributed to the travel company's migration GCP and adoption of Kubernetes. And on the note of Kubernetes, Irvi has presented at various cloud-native technology forums and is also one of the leading contributors to Kubernetes from Indonesia. Hi, Irvi. How are you?
Hi, I'm doing fine, thanks. How about you?
Yeah, great. How are things in Indonesia?
I guess it's starting getting better, and you know that the thing is getting better, and the COVID itself is also starting decreasing for the people who admitted in the hospital.
Okay, great, good. Well, hopefully, it's all a bit weird and up in the air, but hopefully it's all moving in a good direction. So, in terms of the session, as always, we're using Slido for Q&As. And that will be the principal way with which the audience can interact with us through, there's 1 or 2 polls which I'll throw up, and also Q&As. So the idea is for this to be as conversational as possible. Feel free to throw in questions, thoughts as they arise into Slido, and we'll try and address them through this session. So that said, as always, this is the link for Slido. And we got some great feedback from the survey that we had during the last session. And one of the suggestions was that we include the link for Slido during the talk. So that is hopefully visible to everybody at the bottom. In fact, I should be using my hand. When I have a hand, the thing at the bottom. So that'll be visible throughout. And within that, we've got the poll is open at the moment, and it'd be great to, just for starters, to understand where everyone is joining us from. So a great spread from Netherlands all the way through to the hopefully sunny West Coast, London centric, which is great. That's my hometown. Excellent, good. So thank you for those of you who've participated in that. In terms of the next question, going on to the main course of the evening, do you use Bigtable? And it's always interesting to know where everyone is in relation to the tech that we are discussing. So we'll give everyone a few moments to respond to it. Have you used it? Have you do you use it all the time in the course of your work? Have you not used it at all? Yeah, okay. So feeling a bit shy, no problem. We will move on then to the final question, which is how much do you know of Bigtable? Because it is a bit of a slightly off-piste platform, especially for those of us who come from a a more SQL-based background, which I guess is most of the world, using a NoSQL based data store with its own particular type of use cases wouldn't normally be a starting point for a lot of companies. So we're very much in the learner camp. So Irvi, that's interesting. A lot of people here, actually most, are either starting out at the very beginning of their journey on Bigtable or have just started to learn or play with it. So I think that's where we are, and that would be interesting. And I think this talk would be really, really, I think really informative in that sense, in terms of having a real expert and a real heavy duty use case around the use of Bigtable presented and talked through. Great, thank you for that, everybody. As I said, the Q&A will be open right through the session. You can see the link at the bottom. In terms of the agenda, Irvi will be kicking off with the intro to Bigtable, high-level architecture, key structure and tools, and then progressively go into the use case that that Irvi implemented, and the learnings and challenges encountered around hotspots, which are a peculiarity of the way Bigtable is architected. So without further ado, Irvi, I will hand over to the expert, and over to you.
Okay, thank you, Imran. So, hi everyone. I will try to just share about my experience with Bigtable. Here is the use case when we actually can use Bigtable. So basically, it will be good if the data is large enough, within the limit of at least 1 terabyte, and otherwise the overhead will be too high. And this will be discussed why in the next slides. And for each rows, only contains less than 10 megabytes, and NoSQL or multi-row transactions. And the data itself is stored as the key value pairs. Next, for the example, for the use cases for Bigtable is including Google Analytics, personalized search, YouTube, advertising in Twitter, IoT and sensor data management and analysis for GeoMesa. And this is the example of how Bigtable used in GeoMesa. So basically, let's say that we have a geographic map for a country, and then we have certain landscapes like roads and natural things like rivers, lakes, and political regions like capital city, and we want to model this as certain shapes, and then we can save it later. And how we can use this data and encode it into Bigtables, like how can we store data itself? So the next is we can actually define it and give a proper modeling for each of the data. So let's say that we have the data for these specific maps. We can create a key for each of data itself by using this formula. And I think for the row key itself is the most important things that we need to learn. Why? Because this will affect how we can access the data itself. And this will be discussed later. So, and then how Bigtable architectures in general. So there is few components. The first one is client, where we can actually connect to the front-end server for the Bigtables. And this front-end server itself will be connected to each of the nodes. So Bigtable itself is actually a cluster here. And for each of the nodes, for the cluster will be called tablet server. And underneath it is actually the Colossus, also called GFS. So here we can get the architecture of SS table, and then share log where we can make sure that all of data is shared properly for each of the nodes itself. And then here's the client connectivity. So let's say that we have a client here, just like what I mentioned before. There will be a load balancer, and the processing will be done in the level of nodes. And the next, there is already various clients available for Bigtable. So absolutely, we have C++ and Golang, and then we also have Java, and many other languages that actually can be seen in these links. If you want to choose whatever things that you want to use. And if you are still playing with it, I recommend you are using CBT or edge-based shell, because it will be easier to create and define the key or identifier needed for the instance itself. And then, so what is the purpose of the API here? The API is used, of course, to create and delete tables and column families. This will be discussed later. And we also can rescale the cluster, and then have the ability to write and delete rows values here, perform lookup or create a range scheme for certain data. And then just like what I already mentioned before, we can use a quick start using CBT or edge-based shell. And next, here's the example of Bigtable data models. So basically, Bigtable is like 3D map, which is indexed by a row key. I think this is one of the most important things, because yeah, it will define how we can access data. But there is a limitation on the size of the row key itself, and the operation for each of the row is atomic. And then we have a column key, and we have a timestamp here. So each of the value is represented as array of bytes. And then here is the example of how the data is stored. So here, whenever we create a table, we will need to define a column family here. And for each column family, we will have a column qualifier. And here we will have a rows, which is also have its own of key here. So basically, data in rows will be sorted lexicographically, and the data is partitioned, and each of the row range is called a tablet here. And for the tablet itself is the unit of distributions and load balancing whenever we need to resize the size of the cluster. And one thing that may be affecting the performance of using Bigtable is how we define the key, because because we know that data is sorted. So if, let's say, we are creating a monetically increasing key, it will be kind of not spread properly for each of the tablet server or the nodes in the cluster. And so we will need to make sure that the row key is already defined carefully. And there is cells. So in Bigtable, actually we store data as a version data, and it will be it will have kind of metadata of timestamp, and the latest data is actually will be shown, but we also can access previous data by defining the version that we want to fetch here. And we can also provide the expiration time for the column family level here. So let's say that we don't want to keep certain versions of the data that we store, we can define it in the column family name here. And after that, here I have a case study for the advertising analytics for Twitter. So for example, here I have this kind of data: the timestamp, advertiser ID, campaign ID, engagement type, and display location. So how can we define the model of data for this kind of schema? So first of all, we can concatenate all of the dimensions here. So we will join all of things here. And the pros here, we will have an easy scan for all of the advertiser based on the time. And we will have a good data locality here. But the cons is there is possibility of hotspot, because if, let's say, we are using timestamp here, it means that since we know that data is stored in sorted order, the spread of the data for each of the nodes itself won't be balanced. So there is a possibility that the CPU usage for certain nodes will be higher than the others nodes in the cluster. So how can we improve this schema here? So the next iterations will be like this. So we still do the same. We concatenate all of dimensions here, but we will have the keys for the rows as the join for the advertiser ID and timestamp here. It will be easy since we still have the identifier for the advertiser ID, and we also have the identifier of timestamp, so we can sort the advertiser ID based on the timestamp that when we add the ID. The cons here is we will be getting harder in terms of query all of data. But however, for this specific case study, it's not really common for query all of the advertisers. So we can still stick with this design. Okay, so because we still have the possibility of getting a hotspot where the key is not balanced for each of the key that we are using, we can use a key visualizers to see if there is a sudden peak or too much heat map for certain key. And after that, based on this case study, is turn out that the advertiser campaign is in the terms of increased values. So to avoid this hotspot, we can just reverse the advertiser campaign, so it will be spread better in the cluster, and so we will get this kind of schema in the end, and we can also get, or at least decrease, the possibility of getting a hotspot here. So so the most important things is defining the row key, because it will be affecting our schema, and the schema itself will be affecting how the data is being accessed by our pattern of read and write for the data in the Bigtable itself. So we should make sure that the key is already accommodate common query. So previously we know that for this case study, we know that for query all of the advertiser, it's not really a common usage. So we can trade off this use case for getting a simplified schema, but also still making sure that the key is distributed well here. So the things that we need to avoid is like using a timestamp. That's why in the previous slides, from the first iteration to the second iterations, we change the key from the timestamp here to the join of the advertiser ID and timestamp. So we need to avoid a sequence type ID. And combined key will be also helpful as well. So it means that we concatenate certain identifier for one row. So if, let's say, we know that the traffic will be increased in certain period of times where we getting much more higher throughput that than we are usually have. So we can actually doing some kind of rebalancing here. So let's say that here we have this kind of diagram here. So we have the pointer from the nodes to the storage, and then how the rebalancing works is actually moving this pointer for the client to the nodes, and then as we can see here, we move the pointer for the storage for C to more to the other table here, to the other node here, because the first node is already taking too much pointer for itself. So the data won't be balanced in this case. So that's why for the second diagram here, we can see how we remap how we store the key or metadata for each of the nodes. And if we are doing resizing, practically we are trying to rebalance the key as well, because if we add or decrease the size of the data, the cluster size, it means that we add or decrease the number of the nodes, right? So it means that we need to make sure that the data is also rebalanced in the terms of the key spread and stuff. So if, let's say, the rebalancing is going well, the Bigtable throughput will be increased in linear times, just like how we increase the size of the nodes. So this is also affected by how the write and read pattern when we are doing rebalancings. And this pattern of write and read also being affected by how we design the schema. So here, for how we can design the schema is actually several general concepts. So for example, for each tables, we actually only have one index, that is the row key. And for the rows here, we already know that it's sorted. And for each columns, it will be grouped by column family. So whenever we create a table here, we can also define the column family name. And all of the operation is on the atomic level, on the row level. So we also, ideally, we can make sure that both of reads and writes should be distributed evenly. And for related entities, let's say that we want to find some kind of distances or cluster for certain regions, we can make some key that defining if this cluster is if several cities is actually nearby to each others. So and this kind of entities is actually can be stored in adjacent row. So when we are doing some kind of range scan, it will be done more efficiently. So here, the performance for Bigtable is really heavily affected by how we design the row schema. So just like what I said before, the row schema will guide the access patterns of the data. And when we have some kind of unbalanced access pattern, it will be causing a hotspot here. And whenever we shift this balanced access pattern, we will get the linear scaling. It means that the higher size of the cluster, we will also have make sure that the cluster will be able to handle the throughput in the linear time. So the problems encountered is, let's say that we have some kind of a peak period for a certain time range, and there is like high and write and read operations. However, in the terms of adding the size or decreasing the size of the cluster itself will typically need sometimes like around 20 minutes or so, and it will be also depends on the size of the cluster itself. If let's say we are adding too much cluster, it means that the mechanism of rebalancing will need more time than when we only increased smaller amount of nodes to the clusters. So it also depends on the incoming traffics as well, and we can also track if the rebalancing mechanism is already done well by the key visualizer. So simulations here, if let's say we have two clusters here and it's evenly distributed for the traffic, and then suddenly we have some kind of more access pattern for certain key here, and it will be causing a hotspot for, let's say, the key of G located in node 1. So it will kind of causing disturbance in the latency for read, because all of read access will be load balanced into the node 1 only. And if let's say we are trying to reduce the latency by increasing the nodes, it still doesn't work well. Why? Because still here 85% of the traffic still redirected into this node 2. So this is not really a good patterns of defining the key. And here we can define the P99 for the affected key. So let's say that we have traffic for clusters. How much RPS for the traffic itself, and we can define for, let's say, this specific hottest key and median key access, and we can also have here the size of the clusters. And yeah, the P99 is actually this patterns. And the common way to make sure that the key distributed evenly for this cluster is actually make sure that the first approach is actually hash all of the key by using non-cryptographic hash functions. So it will be faster when we are trying to retrieve the key. All, for example, for sorted key like timestamp or maybe cookie ID or campaign ID that we already see in the previous slides, we can just reverse all the key, assuming it's in numerical order. Or if we have intuitions, if there is certain key that will be accessed more often, we can actually promote those random field as a row key here. And for example, if we already in the state of resizing the Bigtable cluster and then waiting for the cluster to be rebalanced, we can see the usage for the CPU inside of the cluster here. And if we see many peak period like this, we can deduce that it can be only because of high CPU usage, or whether there is a possibility of getting a key hotspot because of the design of the row key. So here, we can also use a key visualizer. It is practically write and read access patterns over times. So the horizontal line is actually time, and it will be generated by the heat map of the nodes. And the usage itself is actually find or prevent hotspot by looking at the vertical key space here. Here we can see the key that actually the key usage for every timestamp here. So the range can be blue to white or silver. So if it is blue, then it is good. But if there is the silver line, usually it is a sign of hotspot. And the other usage for key visualizer is actually find if the rows contains too much data, or simply to define if the schema is already balanced or good. We can do some kind of iterations just like our previous study case, where we try to design some kind of schema, define the row key, and then trying to do some kind of simulations of the traffic, of the incoming traffic, and look at how the access patterns in the key visualizers, if there is no signs of high CPU spike and the heat map is just fine, then we can use this key. But we should take note that how we define the key is maybe not that obvious when there is a change in the patterns of additional maybe information for data. There is also a possibility that we need to change the key, something like that. And so one thing that we can do to prevent key hotspot is actually before we are getting increase in the traffic that we got in our services, we need to make sure that we already increase the size of tables nodes. And after that, to make sure that the rebalancing is going well, we can kind of try to random access every key that we got so that it will be dispersed for each of the nodes. Here, I create some kind of example on how we can do the random access based on gRPC protocol. And we can actually try to use a Bigtable here by using CBT. However, if you are using macOS, there can be some problems with your OpenSSL, so you need to use certain OpenSSL that actually installed in your macOS. And so here I have an example. So I have a tables here. The instance of my clusters is named the COVID datasets, and what I want to do with this is actually read this specific table of idly dataset for COVID. So if you are already authenticated to Git Cloud Console, then you can just try to use this. And so there's actually many data here. This is a raw data that being stored in my tables. It's a summary for several days. And the key itself is actually the hash of of the region. So if I wish to do that, I can kind of scan nearby region to find if the spread of the COVID for each nearby locations here. And what I stored inside of my Bigtable table is actually just a JSON value. So here I also provide some kind of how we can put data into Bigtable here. So I can populate the data here based on dataset that I get from Kaggle, basically. And what I want to do is like doing some kind of range scan. So the things that come to my mind is make sure that every connected region that I want to see is located into a certain range. So the scan won't be that expensive to be done. That's why I'm using some kind of hashing mechanism for that, just to make sure that the closed region will be located into same nodes. So it's like this, and after that I just put all of the summary data that I get from the data set into JSON and then store it into the table. Then basically CBT is just like an HBase shell, but the syntax is kind of different here. Whenever we are using CBT, we also can kind of create an instance or a table from our command line, and we can also define the column family for each of the tables that we have. So I think that's all for my presentations now.
Thank you, Irvi, for a really informative and quite a comprehensive talk through of Bigtable. Certainly the architecture is impressive and interesting. So we have a few questions which we can try and address. One has been answered on sorted table. What is SS table? And the answer that came back is a sorted strings table, a file of key value string pairs, sorted by keys. Anything to add to that, Irvi? Thank you for whoever answered it, by the way.
Okay, so first I want to answer the questions about how to change the row keys we find hotspot. Can it be done online? So basically, just like what case study that I gave before, if let's say we find some kind of abnormal patterns for the heat map, and we can see which key that actually being impacted, we can change the row key here. But the thing is, if we already find a better row key, I think we need to change all of the previous row key, right? If let's say we want to change the design from only timestamp and then we want to change it into the combine ID or anything else, we need to update all of data during our findings about that. So can it be done online? I'm not sure about it actually. And for the question about SS table, yeah, it's actually some kind of tables for key and value store, and it is sorted, and it's technology used by Google. And I actually have some kind of paper for the access table here. I have provided. So if you want to some kind of learn more about access table here, it's also used for level DB actually. And the paper is quite old in 2012. Here we can see how it's actually implemented. And is there any way for GCP to intelligently amend rows key to avoid hotspot? So I think it should be done manually. As for how we define the key itself, it's actually being done in relatively iterative manners, because sometimes we didn't find the fact that the data, like what I mentioned before, is campaign ID turns out to be sorted. So we need to reverse it to make sure that the storage for each of the key is sparse enough for whole clusters. So I think that's all. Because for the access table, it's already answered by the first questions.
Thank you, Irvi. So clearly the construct and the specification of the key is pretty critical to the usage of Bigtable. I have a question actually around replication, which Google introduced last year for Bigtable. Have you had any experiences with that? Something I was curious about was whether there are any guarantees around consistency if it's being used in that distributed.
Okay, so basically the things that being stored in the node itself is more about the metadata, and all of data itself is stored in the Colossus or GFS, and all of the nodes is actually have the same access to the GFS, which in turn contain the access table. So I think it should be consistent enough, because the read and write patterns for each of the rows should be atomic. So it should be consistent.
Okay. Okay, great. So if there are no other questions, oh, no, we do, excuse me. Or do we? No, we don't. So Irvi, thank you very much for a really interesting and illuminating talk on Bigtable, and hopefully it's given everyone food for thought in terms of their own use cases and whether it fits into the kind of applications or challenges that they're looking to address. On that note, in terms of GCP's own NoSQL stores, I guess Firestore is the other one. Any thoughts on the usage of that as a lower, slightly off topic actually? So if you, I don't know if you've used that or come across that in any way.
Okay, so for Firestore, I think there is several limitations, since let's say that we store some kind of nested JSON string, and usually we store in Firestore as an object, right? If we want to store this kind of nested JSON object as an object in Firestore, there is a limit of depth of the nested object as 20, I believe, and it's also restricted in terms of size of each of the rows. However, for the process, actually, we don't need to some kind of rebalancing mechanism or resizing the size of the cluster, because we don't really know the underlying mechanism of how it's being scaled. So if let's say that the data is quite small and it's only key value pair and it's not really that complex, then we can use Firestore actually.
Okay, interesting. That's slightly off topic, so apologies for going off piece there. So thank you first and foremost, Irvi Aini for again a really informative talk. This talk will be available on demand, and as will be the slides. We have a survey here. Get any additional feedback. I believe that should be in the comments, and it'd be great if everyone could just spend a few minutes to give us their thoughts on how this went, how we could get better in terms of the way we present, and also the kind of topics that you'd be interested in learning more about. And on that note, if anybody wants to present, then again, feel free to contact us. I will say subscribe. I don't know why I say that, but subscribe. I think it's a good thing. So on that note, thank you, everybody. We've got another great talk in a fortnight on dataproc, democratizing dataproc from Jamie Thompson at dunnhumby. And that's going to be a mix of some good stuff in terms of Hadoop, Composer, and data science use cases. So I highly recommend, there's something there for everybody, I think. So highly recommend joining that. Irvi, thank you again. And hopefully we'll be able to have you on here again with another equally informative topic. So on that note, thank you, Irvi. Thank you, everybody. Goodbye.
Thank you.
Stay safe.
Bye.